So today we continue solving trig equations. We've solved first degree equations, we've solved second degree equations that were factorable. Today we move into some things that are not necessarily factorable. Don't take factoring out of your vocabulary altogether, because lots of stuff still is, but you need to be able to solve things that are not factorable. So just some reminders: when we have non-factorable quadratic equations, we can complete the square or use the quadratic formula. So let's see. Again, parallel problems. They're exactly the same, except these are x's and these are cosines. Math is consistent. I like to show you in algebra because that's what you're more comfortable with, and relate it to the cosine. All right, so here this is not factorable. There are no numbers that multiply to 2 and add to -4. I wouldn't complete the square, because if you did, you'd have to divide by 2 first, and you're going to get a fraction out here, which may freak you out a little bit. So let's practice our quadratic formula. So again, the quadratic formula, you should write when you're using it so that people grading papers know what you were thinking, and then we plug in. So here x is the negative value of b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. Clean it up. So we have 4 plus or minus the square root of 8 over 4. We can simplify that square root. This is 4 times 2. So we have 4 plus or minus 2 root 2 over 4. You can reduce. 4 divided by 4 is 1. 2 divided by 4 is 1/2. You can reduce your coefficients. So solving algebraically, I would be done. Now, the same would happen when you solve with trig. And it's exactly the same, quite frankly, except instead of x equals, you have cosine theta equals. Okay, so I'll write the first step. B squared, or negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. But I'm not going to waste my time doing that again. You've already done that. So I'm just going to come straight here, and instead of x equals, I have cosine theta equals. So now I know that cosine theta equals 1 plus or minus 1/2 root 2. I'm going to break this up to help me. So cosine theta equals 1 plus 1/2 root 2, and cosine theta equals 1 minus 1/2 root 2. Okay. For the first time, these are not values on our unit circle, so we're going to need to use our inspire to finish. Now, before we do that, let me remind you how this works. You're solving for theta, so we need to find the angle measure. When you're finding the angle measure and it's attached to a cosine, you need to inverse your cosine. If it's attached to sine, you inverse your sine. I write that to remind me how to use my calculator. So here I have inverse cosine of 1 plus 1/2 root 2 equals theta, and inverse cosine of 1 minus 1/2 root 2 equals theta. This reminds me again what to plug into my calculator. So let's go to our calculator. Okay, so push your trig button, find inverse cosine, and type your expression exactly as you see it on your paper. So 1 plus 1/2 times the square root of 2. Push enter, and you get undefined. So there's no solution for that half of the problem. There's no angle measure that meets those requirements. So you're going to want to take your previous entry and copy and paste it, and just change the plus to a minus. Push enter, and we get 72.96 about 73. So we go back to our paper and jot down our 73 and our undefined and go from there. Wrote down my 72.97, rounded to 73. Remember, we always solve for all possible values. So I got 73 in quadrant 1, which meant that cosine was positive. I now need to find its quadrant 4 equivalent. it's the rule for quadrant 4 is subtract that quadrant 1 angle from 360. 360 minus 73 is 287. So your solutions to this problem are 73 degrees and 287 degrees. Tan theta minus 5 equals 0. It's not factorable. I can try to find two numbers that multiply to negative 5 and add to negative 2. There is no such thing that are nice, so I'm not going to factor. I do recognize, though, that if I wrote this without the tans but just with x's, x squared minus 2x minus 5 equals 0, that's a nice complete the square setup. A is 1 and b is even. So I'm going to complete the square on this. I move c over, I make my b list. From my b list, I add half b squared to both sides. So I add 1 to both sides. Now the left side's a perfect square. I put my half b term in parentheses with x, combine the right, and solve. X minus 1 is plus or minus square root of 6. Add 1. X is 1 plus or minus the square root of 6. Now the truth of the matter, though, is we were really solving for theta. So tan theta is 1 plus or minus the square root of 6. I'm going to split that up into tan theta is 1 plus root 6, and tan theta is 1 minus root 6. And then again, go to your Inspire and let it do the rest of the work, much of the rest of the work for you. Again, it's an inverse function. This time I'm finding tan, so it's inverse tan, first of 1 plus root 6. And I get about 74 degrees, and I jot that down. I edit that previous entry and just change it to 1 minus root 6. Remember, arrow up, hit enter, copy, edit, change the plus to a minus, hit enter, and I get negative 55 approximately. So again, go back to your paper, jot that down, and do the rest of the necessary math. 74 and negative 55. Well, let's start with 74. 74 is in quadrant 1. 1 plus root 6 is positive. The other quadrant in which tangent is positive is quadrant 3. So I need to figure out the child of 74 in quadrant 3. You do that by adding 180 to it. 74 plus 180 is 254. So two of my answers are 74 and 254. Now I also got negative 55. We want positive answers. So first you need to take your negative 55 and turn it into a coterminal positive angle measure, which is 305. There's another answer. We got a negative 55 because tangent was negative. I need the 55 child in the other quadrant where tan is negative, quadrant 2. So I do 180 minus 55, and I get 125. So here I have my 4 answers. That's it. Keep practicing that unit circle. See you tomorrow.